tools and technology for designing artificial soundscapes. The tools considered provide opportunities for real-time sound generation. A more detailed description of the methods is presented in the article devoted to the preparation of artificial soundscapes for man-made objects. Since the purpose of this study is the analysis and practical application of generative methods, the main focus is one digital technology processing audio recordings taking into account spatial, dynamic, and frequency characteristics, as well as creating sound using synthesis without using ready-made audio files. Next, we will consider the approach to synthetic audio within the framework of this thesis project. Synthetic audio combines methods for generating, processing, and combining audio elements using algorithms and specialized software. Within the framework of synthetic audio, generative audio is distinguished, focused on algorithmic sound formation. This approach makes it possible to create variable and dynamic sound environments capable of adapting to changing conditions and user interaction. Generative systems are especially valuable for interactive and adaptive applications where audio is not recorded in advance, but is generated in real time based on set rules and input data. Procedural audio is considered as a special case of generative audio. Here, algorithms use physical models or system simulations to generate sound based on environmental parameters. The method preserves the key properties of generative audio: variability, dynamism, and adaptability, while providing tools for creating realistic or predictable sound processes. The use of procedural audio allows you to create soundscapes that originally respond to the listener's actions and changes in environment. Sound elements can be processed, combined, and transformed algorithmically, which provides a wide range of sound options and flexible parameters setting in interactive systems. The main advantages of the procedural approach include wide variety, generation of a wide range of sounds, memory savings. Audio is created in real time without storing large audio files. Dynamism: the sound environment evolves over time due to algorithmic changes. Adaptability: sound reacts to user actions and changes in environment. So, this can be represented as nested levels. Synthetic audio is general class of method, generative audio algorithmic sound generation with variability and adaptability. Procedural audio, generative audio controlled by a physical or system model of sound production. False: procedural audio does not contradict generative audio, but rather acts as its natural subset, which simplifies visualization and demonstrates the logical structure of approaches to synthetic sound. The implementation of generative procedural audio requires a deep understanding of programming, algorithms, and features of the chosen framework. The project uses specialized audio libraries and game engines to implement these methods, including the development of algorithms and the formation of the audio resources. To implement procedural audio and generative music, the project uses specialized audio libraries and game engines that provide high flexibility and accuracy in creating sound environments. This process includes not only writing software code and developing complex algorithms, but also preparing audio resource, structuring them, and integrating them into an interactive environment, which allows you to create lively, adaptive, and unique sound compositions capable of responding to viewer behavior and spatial features. So, very structure of the tool's lifecycle. It all starts with a text code that is compiled and added to the list of available audio engine tools. Next, the step is performed the tool is associated with the necessary parameters and is being prepared for operation. After receiving the trigger signal, an instrument object is created which begins to generate an audio stream and function in real time, while optimizing system performance. The implementation of procedural sound requires deep knowledge in programming and algorithmic, as well as significant computer resources, which directly affect the performance of a system. Examples of successful application of procedural audio are found in various fields. Thus, in the simulation game sport, dynamic generative music adapts to the player's actions and characters' development stages, creating a sense of a lively, constantly changing soundtrack. In Minecraft, a popular sandbox game, procedural sounds form audio in virtual world of blocks, steps, disruptions, and interactions are generated in real time, responding to user actions. Similar approaches were used back in the 1970s. In musical installations such as Bloom, Brian Eno, created sound generated in real time are responding to the listener's actions, laying the foundations for ambient and interactive music. In the 1990s and 20s, the development of digital technologies made it possible to create more complex generative audio environments. Modern projects, including BBC Sound audio performances, use dynamic sound environments that change depending on the plot in changing emotional perception. In music practice in the West, generative sound is actively being introduced to create an immersive experience. For example, MoMA Museum in Modern Art in New York, Tate Modern in London, sound installations complement visual expositions, providing a personalized experience. At the Smithsonian Institution, multimedia exposition allow visitors to influence sound through touchpads and interactive devices. This experience demonstrates that generative sound can become an independent expressive language of a museum environment, expanding curatorial capabilities and increasing the level of interactivity. In Russia, after the May 2010s, there has been an active introduction of interactive and adaptive technologies in museum and exposition projects. Of particular interest are sound environments that can dynamically respond to visitor actions. Among the existing practice, generative and procedural approach to the organization of sound are distinguished to ensure the variability and adaptability of the acoustic environment. Examples are the projects of the Planet 9 Bureau, where the expositions include first position Russian ballet, Balabanov, and pan culture, The King and the Fool. Uses adaptive sound design. When a visitor moves between exhibits, the sound in the headphones changes in real time depending on the position of a person. In addition to the Western experience, interactive sound environments are also being actively introduced in Russian museums. For example, the Garage Museum of Modern Art and the Pushkin State Museum of Fine Arts use generative and procedural audio media to create immersive exposition. At the same time, curators and museum staff are responsible for the conceptual design of the exposition and the selection of the material based on theoretical approaches to soundscapes. Examples of such solutions are presented on the Garage Museum's website in the descriptions of the experimental sound festival prepared environments. In the Pushkin Museum, media technologies were used in multimedia projects such as Pushkin with Pushkin, where the sound component plays a key role in navigation and interaction with visitors. In cinema and virtual reality, experiments with procedural sound generation are becoming especially relevant. The audio environment changes depending on the direction of the viewer's gaze or head movement, creating the effect of a complete immersion. Procedural sounds and generative music make it possible not only to accompany user actions, but also to make the environment more lively, dynamic, and emotionally intense. Understanding the advantages and limitations of such technology helps to create adaptive audio system that enhances the overall experience of game, interactive installation, or multimedia project. The introduction of procedural sound opens up new opportunities for creative expressions and audience engagement. Thus, these examples can serve as a basis for developing a database and integrating audio into your own projects.